Hello everyone. Today, let's work through this chapter's solutions together. I've prepared these practice questions so we can solve them step by step. Now, I want to start with the first question is about the Caesar cipher. Let's open a new file and start coding the Caesar cipher. We have string. We need to specify to shift that by how much. You can think of it like this. For example, if you shift it by 3, it becomes wraps back around to C. Yet, the question requires all letters to be uppercase. You won't go outside the alphabet. We can't go outside it anyway. We'll do this using there's actually a hint provided in the question for this. We'll work with that. Now I've opened up a new project for this first question. First, I type string, then name it message, and close the statement. Then I declare an int, name it shift, and close the statement. Then I declare a SHA variable because we need to iterate through each character. After that, I declare an integer. This integer will hold the value of each character. Then I declare the message variable like this. We'll append the encrypted characters to this one by one. Which characters? The encrypted characters. Oh wait, we also need to set up the scanner. Because of this, we need to read the shift value and the message from the user. I type the message prompt. You can see I use scanner.next and scanner.nextInt to read these values. Here's how I write it. What will the encrypted output be? The overall logic is already clear from experience. Today we're getting that hands-on practice. At the moment, at least, we've handled the two input parts. We've handled these two parts. Now we've arrived at the core part. We've come to the real challenge. Don't be intimidated by the word difficult. There's just a little trick to it. First, I open a for loop. I define a variable and initialize it to 0. I write I is less than message length, and I hit. We want to iterate through each character in the message using the index I so we can access every single letter. Here's how I did it. First we get the character at index 0, then index 1. That way we've actually gone through the entire string. Now here's what we're going to do. I get the character at index from the message. I add the shift value. This does the following. It shifts the character forward by the shift amount. Then we get to the actual logic. We write an if statement. We check if it's greater than 90. ST90 is the uppercase letter Z, so anything above 90 is outside the alphabet. Here we write 65. Now, to avoid confusion here, let me illustrate this step. Say the integer value is 92. Subtract 65 from it. Take mod 26, then add the 65 value between 65 and 90, which maps back to it through ZI. We first write the cast to char, but we're not done. We also need to write this. Think of it as concatenation. You can think of it as appending to the string each time. Well, that's exactly what it is. So the first encrypted letter is added, then the second, then the third, and so on. Think of it as continuously concatenating them. We should have done it correctly, hopefully. Let's test with hello. Hello, shift by 3. Looks like it worked. The second test is Java with a shift of 25. Pizzas came out. Correct? Well, that's all for the first question, everyone. Now we'll work on the second question. What kind of question is the second one? The second question is like this. Here we have a menu of options. 1, 2, 3, 4. We display this to the user and it runs in a loop. So we need to print a menu. There's a while loop here. It'll keep running until the user enters 0. When they enter 0, it will add on top of that. There's a switch statement. The switch will handle the product selection. And there's also an option to insert coins. The original question is missing a small detail here. Here, all the cases have an insert coin step. I think we can improve this question a little. We can add one more option here. That'll be option 5, insert coin. And we can initialize the coins variable to 0 at the start. First, I'll have an int variable called coin. Alright, what else do I need? I need to read the user selection here. I'll define that here. Nothing else is needed. Now let's stop here. Let's set up the while loop. Set it to true. Because we only exit when the user enters 0. Let's print this part. Let's paste this in. And we also need to remember the UTF here. And now that part is done. Now should the first condition check? The first condition should check this. Let's also define a variable here. Actually, I assigned it again. Let's say, what was it there? Let's do it like this. And let's define something here. Let's define an integer variable called select. Now we'll write something like this here. Now at the start, we need to check this. We check if select equals 0. If it equals 0, we'll say this. We'll print what we wrote here and then break out. We can also say lookout, or we can say goodbye. Now from here on, the question expects a proper structure. The question asks us to use a switch statement and a while loop. We've handled the while loop. We haven't used the switch yet. For the switch, we'll do it like this with select. Now let's switch on select again. It shows as empty because we haven't filled it in. We'll fill it in ourselves. We'll say, what will we do for case 1? Also, for coins, we need to do it like this. We need to initialize it to 0. First, I assign the coin, then the comparison. We'll write, if coins is greater than or equal to 75, the price of cola. We'll say, pull that here. String builder. Let's try string builder. Let's try using the string builder. And we'll pull that here. We'll pull one here. We'll pull this here. And here we'll do a math operation. Here. No. Now the first part is like this, and the second part, since the else is a single line, we can write it like this. What will we say? We'll say not enough. Written like this. I took it like this. I pasted it like this. What price did it say for this product? And it wants it for chips, which is 90 cents. We'll do this here. Here, we'll do the reverse operation. Let's do it once like this. Now we've at least finished the first case. Here is case 2. We have the second case. What was the second product without alter? We write water. If what was the price? 50. So we'll change this to 50. We'll change this to 50. We'll change this to 50. Look, I said it, but I didn't notice something there. Case 2 is done. Now we're on case 3. This will be given there. What was case 4? What was the price for chocolate? And of course, what did we forget here? We forgot these. After each case finishes, we need to write a break. And now we've arrived at the last one. We're not just doing a calculation here. Then let's say add coins. We type int, we say scanner, next int. First, we need to check this. Initially, coins were 0. We'll add something to coins. Now there's something here. We need to do it like this. Extract one more value here. Less than or equal to 0. It's invalid. If something else happens, then we can say this. Or we can write it with UL. Now there'll be one more. And on top of it, we say this again. to 25 cents change. Okay, that seems to be working too. Let's also check the last one. When we select 0, hit exit. Done. The second question was a fairly long one. When we enter 5, we get invalid value. And if we use option 5 first, and then enter 100, it also shows invalid value. So right now, our balance is 0. That's the logic of this question. It's a somewhat long question. Now I want to take a quick look at the third question. By the way, you can say goodbye. We said exit. Goodbye might actually make more sense. Now we've moved on to the third question. The third question now is this. We have a do-while loop. The do-while works like this. It says, keep running as long as the password is not strong. In other words, exit only when the password scores 4 points. Alright, first of all, I need to declare variable called score. I need to declare the password too. Why are we declaring these? Because the user will enter a password. In the meantime, let's assign score to 0, because it might have a leftover value from the last iteration. If you do on it, you'd get a wrong result. It's usually 0, but sometimes it might not be. I need to mention that. It's a bit memory related. That's why you should assign it to 0 like this. Now if the score reaches 4, we print plum password accepted. For anything else, we handle it as follows. If score is greater than 2, we'll do this. Or if score is above that, it currently shows as always false. That's because we haven't done the calculations yet. That's why it looks that way, by the way. The unreachable code warnings below are also because of that. In the else, I'll write weak, password not accepted. Now I've at least finished the overall loop structure. Now first, I need to check rule 1 to earn 1 point. The password Length must be sufficient. I type password length and check if it's EVA8. So if it's at least 8 characters, we do this. I've come to rule 2. What was rule 2? Does it contain an uppercase letter or not? Here we need to open a for loop, just like we did in the previous question. We write password length and the job of this jar variable is to let me examine each character in the password. So I'll look at all the characters in the password and say, because the question asks for uppercase letters greater than or equal to A and less than or equal to C. In other words, is there a character between ASCII 65 and 90? We write scoring and then immediately write break. The reason we write break right after is so that the loop doesn't continue running unnecessarily. This is a memory optimization. It allows us to finish the operation faster. If you don't write it, well, there's another reason too. Exit as soon as you encounter it the second or third time. You'd increment the score multiple times. Now, if you find 4 uppercase letters, you'd get 4 points. That would happen if you didn't use the break, so the break is required here. The same logic applies below as well. Because rule 3 also says between 0 and 9, we say greater than or equal to 0, or equal to 0, less than or equal to 9 as well, to 9. That handles that rule. What does the last rule ask for? Don't use contains or index. Only chat up. The length function is very helpful here, so it makes sense to use it. That's part 1, that's part 2, that's part 3, and part 4 is this. because we're checking for exact characters. We still have more symbols left, hash, dollar, and percent, so we'll add those too. Now, after these operations are all done, that the password has been accepted, it says weak and prompted for another attempt. Now we're getting a point for uppercase, a point for digits, and a point for the special character. But it's still 3, because we didn't reach 8 characters. It gave 7. Why did we get 7? Everyone. We got 7, and it didn't exit, because it should have been 4. It's time to check. I see something here. Let me look at it. There's a mistake here, for example. We forgot to write break here. Now let me test the last one more carefully, because it probably passed through that. Why did this happen? Let me check that fully. It says code is never used. Why would it not be used? I don't understand this. There might have been a simple bug at that point. Some kind of mistake happened there, not entirely sure. We need to reset the score to 0. We forgot that. I'm sorry about that. We forgot to reset score to 0 in the loop. The logic was right, just that bug. This question wasn't that difficult in my opinion. Well, it's a somewhat tricky question, but still. But now we can move on to our last question. It's a digital root question. It looks like it'll take a lot of work, but it's actually not that bad. Right now we're just reading a number from the user. Now, how will we calculate this number? Because what we're proud of here is this, what we call the digital root. Sum up the digits of the number and make the total the new number. So 9875, 29, 29 becomes the new number. 298, 11, 5 becomes the new number. And 2. Let's pair those together. Is that 2? So the result. The digital root is read. We extract the last digit using modulo. What does modulo do? Modulo gives you the last digit of a number, but if we always take modulo, after that I write number 20, number 10. Then we have 9,875. Because when you divide an integer by 10 in Java, there's no decimal. So it just gives you 987. No fractional result. Since it's integer division, 9,875, 10 gives 987, not 987.5. And that way, we can extract all the digits. That's the logic. And it's actually stated in the hint. Look, it says take the last digit, divide by 10 to remove the last digit. To show what operation we're performing, First, we start with the current number. Then we go to sum. Then keeps accumulating. Then delete. Our new number will be sum. Finally, it's now single digit. Look, it's now below 10. It's less than 10. Less than 10. So this whole process of modular division is just for taking the last digit and removing it. In other words, eliminating. And the outer while loop continues as long as number 10, checking each digit for the digit. Now let's run it. 29, then 11, then 2. And there's one more thing the question says about the single digit case. So this question is somewhat tricky, but some are really hard. They require effort. Especially here with the nested loops, it gets tricky, but the question isn't unfair. You just need to know certain things. Actually, it might even be one of the simpler questions. What do we do when the value goes past 90? Other than that, the third question was fine. The fourth question wasn't bad either. And I think the last question is a really good one. Anyway, that's everything I had to explain.